alumni and friends, donors, colleagues, faculty, staff, members of the media. I'm Shane Jacobson. I have the pleasure of serving as the President and CEO of the University of Vermont Foundation. Now, please welcome Professor Chris Danforth from the Complex Systems Center at the University of Vermont.
Thanks, Shane. I'm really excited to be here today to talk to you all about some of the work we do at the Complex Systems Center. Innovation in science happens when a new instrument is pointed at a behavior that we don't understand. In the 1970s, NASA launched satellites to take observations of the Earth's atmosphere, and today millions of those observations get pumped to some of the fastest computers in the world to tell us about what the future of the state of the Earth's atmosphere is going to be. And when a hurricane model integrates that data, it can tell us sometimes a week in advance where it's going to hit the coast of the United States, and people can evacuate and it saves lives. A similar revolution in data is happening because of the computers that you carry around with you in your pocket and all the interactions we have with each other on the internet. And because of that, the social sciences are ready to go through a data revolution as well. I'm going to tell you about some of the instruments like the satellite that we've built to try and understand human behavior. Every day, about 500 million messages get posted to Twitter. If you wrote those down on Post-its, they would wrap around the Earth's equator one time. I don't recommend trying. What we do is try and build a collective index of the daily mood using this instrument, using this data. So we've shown that this instrument correlates very well with traditional survey-based approaches like those done by Gallup. We've used the instrument to measure the presidential approval rating and found that words used around the president's name predict that rating 3 months in advance. We've even shown the effect on people's mood when they spend time in nature, among other things. We're also interested in being able to model, understand, and observe how well society is functioning with respect to our physical health. So you could imagine if you looked down on the surface of the Earth from space, you might want people to talk about food as much as they talk about exercise on the internet. So we built an instrument called the Lexico Calorimeter that quantifies the balance between calories expressed by people on the internet in different parts of the United States as opposed to the calories that they spend engaging in exercise. And we've shown that this instrument correlates very well with things like the obesity ranks at the level of states. Focusing on individuals and their health, there are hundreds of millions of people around the world who suffer from mental health problems. Most of them don't have access to good psychiatric care, and almost all of them have a mobile phone. We recruited individuals who'd been diagnosed with depression or PTSD and were active users of social media to be a part of a study, and trained an algorithm to look at the differences between, for example, the pictures that people who were depressed posted to Instagram in comparison with people who had not received that diagnosis. This algorithm identified that people who were suffering from depression posted pictures that were bluer and darker and grayer. They tended to have less faces in them, these pictures. And psychiatrists have known for a long time that people suffering from depression literally see less color in the world, and they spend less time in large groups. So while these results weren't surprising, what was exciting about the study was that these differences were observable to the algorithm prior to the date that those individuals were diagnosed formally, indicating that there's a possibility that your phone, in observing how you move around in the world, your tone of voice, the things you say, the words you use, that this information could be used to get you access to a doctor sooner. So it's very exciting. This paper actually got a lot of attention. There were 2 million papers, scientific papers, published, if you believe it, in 2017, and it was named among the top 20 most discussed by the news media. I'm going to tell you just briefly about a few other projects that happen at the Complex Systems Center, where we try and describe and explain systems that society has engineered, like our complex financial system, where you have individuals investing for their retirement, competing in a marketplace against computers that can execute millions of trades a second. As you can imagine, the types of behaviors that we observe in this system are quite complex. Another engineered system that we study is the power grid. As you know, we're trying very hard these days to integrate renewable energy into the power grid, and we have sources like wind and solar And the technology behind trying to store that energy for times when the sun's not shining and the wind's not blowing, that technology is something that some of our faculty work on. There are also lots of emergent phenomenon that we study that we haven't engineered, that have evolved over time. So pathogens and the way they spread around the Earth. People use computational models to try and understand what the best vaccination strategies might be given people's contact networks. This is a picture down in the bottom left of one of these complex networks. And then arguably the most complex object in the known universe, the human brain. There's another instrument that we're trying to understand the data from called a functional magnetic resonance imaging machine that looks at the way your blood's flowing through your brain and it can infer which regions are active. When you're lying in this machine, you could be thinking about your homework or your math problems or someone you love, and the way that the blood flows through your brain, this tells us about the relationships between your behavior and what it is that happens in your brain. So the National Institute of Health recently gave its biggest grant ever to a group of researchers, including someone here on campus, a team here on campus, to try and study the adolescent brain. And over the next decade, 10,000 adolescents will have yearly scans. They'll have their family's health history, how they perform in school, and how they do on particular tests while we watch their brain. All of that information is going to be made public as a part of this study. And we have a training grant in the Complex Systems Center to try and build machine learning tools to infer relationships between what happens in their brain and their behavior. And in particular, we try and build those machine learning tools to be interpretable. It's called explainable artificial intelligence. So in conclusion, this is probably a whole lot of information for you to digest all at once, but the idea is that in complex systems, the idea is that there are aspects of all of these systems that we can study and understand, and that will give us information about how they all behave together. So there's no hurricane in a water molecule. It only results from the interactions between the energy coming from the sun and the rotation of the Earth and the storage of that energy in the ocean. The thoughts you're having right now are not held in a single neuron. It's through the interactions between neurons in your brain. So putting the pieces back together, that's where a lot of the exciting work is done in complex systems these days. I want to thank the MITRE Corporation for funding a lot of the work that I've talked about today. And through a pilot gift from the MassMutual insurance company, we were able to hire a data artist in residence, Jane Adams, who's here today, to help us visualize and share. Okay, go ahead if you want. So these gifts will allow us to visualize and share and create new complex systems that help the world be a happier and healthier place. In particular, with all of the concerns about privacy that we have these days for our interactions online, I want to mention that Peter Dodds, who you heard from later, he and I are teaching a data ethics class in the spring, and being responsible with your data and the data of your kids. This is something we talk about every day, and how to make sure that when we're improving people's health and happiness with these new instruments, that we take that into account. Thank you very much.